At the end of this video, you will know how to use the factor theorem. Trust me, this is very easy. Imagine you have 20 coins and you separate the 20 coins into groups of 5 coins each. You realize that you end up with 4 groups with 5 coins each and there are no extra coins. Because that is the case, 4 and 5 are considered factors of 20. Now let's find more factors of 20. You can have one group with 20 coins, 2 groups of 10 coins each, or 4 groups with 5 coins each. 1, 20, 2, 10, 4, and 5 are all considered factors of 20. So what is a factor really? Well, a number may be made by multiplying 2 or more other numbers together. The numbers that are multiplied together are called factors of the final number. You must bear in mind that all numbers have a factor of 1, since 1 multiplied by any number equals that number. All numbers can be divided by themselves also to produce the number 1. It is important to remember that every single time. Now let's get back to our example. Remember we had 20 divided by 4 equals 5 and 20 divided by 2 equals 10, 20 divided by 1 is equal to 20. In each of these cases, there are no remainders. So remember that the polynomial is just a number. That means if x plus 1 is a factor of x squared plus 6x plus 5, it means that there is no remainder when you divide x squared plus 6x plus 5 by x plus 1. Now let's divide it for real. X squared plus 6x plus 5 divided by x plus 1 will give you x plus 5 as a result and no remainder. That means that x plus 1 and x plus 5 are factors of x squared plus 6x plus 5. So in case you missed that, let me break it down for you. X squared plus 6x plus 5 is dividend, x plus 1 are divisor, and x plus 5 the quotient, and 0 is our remainder. Which means that when you divide this, x squared plus 6x plus 5 by x plus 1, you get x plus 5 with no remainder. That is what makes x plus 1 and x plus 5 factors of this polynomial. And now this brings us to the factor theorem. It is very simple. It just states that when a polynomial f of x is divided by x minus a, the remainder is f of a. If f of a is equal to 0, then x minus a is a factor. That's it. So now we already know that x plus 1 and x plus 5 are factors of x squared plus 6x plus 5. Now let's use the factor theorem instead of long division. So now we're using the factor theorem. In this case, f of x is equal to x squared plus 6x plus 5. To find the factors of this polynomial, we take the last term, 5, find the factors of 5, and then substitute each one into f of x. In this case, the factors of 5 are 5 and 1. So first we substitute 1 into f of x. We get 1 squared plus 6 plus 5. 1 plus 6 plus 5 is equal to 12. X minus 1 is not a factor. Let's substitute 5. 5 into f of x would be equal to 25 plus 30 plus 5, which is 60. So x minus 1 and x minus 5 are not factors of x squared plus 6x plus 5 because f of a is not equal to 0. F of 1 is equal to 12 and f of 5 is equal to 60. Now let us substitute the other factors of 5 into this equation, minus 5 and minus 1. F of minus 1 is equal to 1 minus 6 plus 5, which is equal to 0, which means that x plus 1 is a factor. Let us substitute minus 5 in f of x. That is equal to 25 minus 30 plus 5, which is also equal to 0, which means that x plus 5 is a factor. X plus 1 and x plus 5 are factors of this polynomial. Sure, that's an easy way to find factors, but before you start using it for every equation, there's one thing you should know. Not all polynomials can be factorized. Yep, it's true. But a quick way to know which ones can be factorized is by using this little check. Remember, your general polynomial is ax squared plus bx plus c. Well, if b squared minus 4ac is less than 0, then the polynomial cannot be factorized. Let's take x squared plus 2x plus 2 as an example. b squared minus 4ac is 2 squared minus 4 times 1 times 2, which is equal to minus 4. Minus 4 is less than 0. So, x squared plus 2x plus 2 cannot be factorized. Okay, if you don't believe me, we'll investigate further. Once again, let's find the factors of 2. These are 2 and 1, minus 2 and minus 1. F of 2 is equal to 10, f of 1 is equal to 5, f of minus 2 is equal to 2, f of minus 1 is equal to 1. F of a is not equal to 0 in any of these cases, so there are no factors for this polynomial.